Okay, so this video we are going to talk about the characteristics of stars. So, since you guys have already learned some of this, I expect you all are kind of familiar with this information. First thing we're going to talk about is, well, what is a star? So, a star is truly a big gaseous ball of, I'm going to say burning gases for lack of a better word, but that do what's called nuclear fusion. So the big ball of burning gases that do nuclear fusion. Another word for nuclear fusion could be hydrogen fusion. Remember, we initially said that hydrogen was the most abundant element in the universe, and this is how a star begins its life cycle, with hydrogen fusion, meaning that it takes in hydrogen atoms and combines their nucleus, and by combining two hydrogen atoms, it's actually making helium. So this is the process of hydrogen fusion, or nuclear fusion. This process gives off a lot of energy, and as you all know, some of the energy you are all very familiar with. Some of the energy would be what, for example? What do you feel? Heat. And what do you see? Light. So you already know these two forms of energy that are created or emitted by stars, but actually it gives off a lot more energy, and that whole of energy is known as the electromagnetic spectrum of energy. So we're going to learn more about this, but just know for now that light and heat are a part of this electromagnetic spectrum of energy. Alright, so that's what stars are doing, and as they go through their life cycle, stars actually use up a lot of the hydrogen they started off with, and then they will begin later in their life cycle, later in a star's life cycle, it will begin to fuse heavier and heavier elements. So it might fuse a helium and a hydrogen and make element number 3, which is lithium, or it might fuse a helium and a helium to create a beryllium. So this is how the elements are being created through stars. So later in a star's life cycle, it fuses heavier and heavier elements. You might have heard someone say, we are made of stardust. Well, if you think about it, if you think that the elements are all made by stars, then obviously we contain elements. So yes, there's a little truth to that. We are made of stardust. So you also should know now that stars, there's a correlation between the star's size and its lifespan. So what is that correlation? Well, the smaller the stars, the greater, or the longer, the longer the lifespan. So smaller stars actually have a longer lifespan than a bigger star would. So while we're talking about that, let's talk about our star. Our star is the sun. And what do we know about our star, the sun? Well, you should know that it is a medium-sized, and it's yellow in color. And you should also understand that our star is about 4.5 million years old, and it's middle-aged. So it has about another 4.5 million years of lifespan left. Okay. So now we need to talk a little bit about the lifespan or the life cycle of stars. And we're going to begin with a new sheet. Let's do that. And let's do this and let's label it life cycle of stars. So we just said that the star's size has something to do with its lifespan. We're going to start out with where stars are born. Remember, stars are not really alive, but we say they have a lifespan because they are born, so to speak, in a cloud of dust, gases, and debris. I'm going to make this cloud here. I'm going to add a little color because there's all kinds of different elements and gases and things like that in there. And this is known as a nebula. Well, what is a nebula? It's also called a stellar nursery. And what does that mean? Well, this is the birthplace of stars. Oh, before we continue, I did want to go back and just say one more thing about our sun that you may not realize. Well, our sun looks rather large to us, but why does it look big? Well, the sun is very close to Earth, and that's why it looks big. But if, let's say you lived on a different star system somewhere out there in the universe, or out, let's say out there in our galaxy somewhere, our sun would look just like another speck of light in the night sky, just like the others do. So the only reason our sun looks big is because it's very close. It's really nothing spectacular. Like we said, it's just a medium-sized star. Okay, so I want to clarify that. Okay, back to the life cycle. Alright, so a nebula is a stellar nursery or a birthplace of stars. You might be asking, well, where does a nebula come from? Nebulas form from the death of very large stars or a supernova explosion. So that's how nebulas form. Okay, since we said there is a difference in size, we're going to actually have two routes from the nebula. If the star is extra small to medium, it will go this route, and if it is large to extremely large, the birth will go this route, or the life cycle will go this route. So depending on the size, like we said, sizes Stars come in all sizes, from extra, extra small all the way to XXXXXL, or extremely large. So we're just looking at the life cycle as it would progress from birth here in the nebula to its actual death. So we're looking at something like an average star, our sun. This would be an average star. Or small, extra small to medium. Something like our sun is medium. So it falls into this category. Whereas this category would be those large to extremely large. This would be a massive star. Okay. So the first thing for an officially to be born or to actually be considered a star is it must be doing hydrogen fusion. So that's where it all starts out. So star is doing hydrogen fusion to create that energy. That's the birth of this star. Actually, how it's, once it's classified as a star, it is actually doing hydrogen fusion. Well, our star is 4.5 million years old. It still has, it's middle age, it still has another 4.5 million years to go. But what happens as it slowly begins to die? What will happen next? Well, the next thing that's going to happen to our star is it's going to start to expand. And y'all all know what expand means, like blowing up a balloon. Not a very good color. Let me find another one. So it's going to get bigger. And this is called expansion. And this massive star is going to get extremely big. So this is both expansion. Our star, or a small to a medium-sized star, is going to expand to create a red giant. But a massive star is going to expand to create a red supergiant. Obviously, supergiant implying that it's larger than just the giant. And this is when it's starting to die off. So all hydrogen is being used up. And it's actually creating heavier and heavier elements. Creating heavier elements. That's when this expansion will begin, when these things are happening. Alright, then what happens next? Well, let's look at what happens to a star the size of the sun first. So once it's done, it's used up all its helium and used up all the elements. It cannot fuse anything else. It will actually become, after expansion, if it expands so and so far, then that's the end of it. It will now become a planetary nebula. All this stuff will be thrown out in a certain area. Remember, probably all the planets and all that's going to be gone with it. So our small stars all the way up to our medium stars like our sun will become a planetary nebula. And remember, we've looked at nebula already. We already know that a nebula is a birthplace of stars. But this one specifically says it's a planetary nebula, so it's probably not creating stars because it only had that one medium-sized star, so taking our solar system. But all these rocks and gases and things that were once in our solar system are now mumbled up in this nebula. Alright, but the massive star, what's going to happen to those large to extra, extra, extra large stars? Well, they're going to undergo what's known as a big explosion, which is called a supernova explosion. And remember, we just said, oh, a nebula comes from, so stellar nursery is actually the result of this supernova explosion. So in this instance, this thing has a lot of gases there, a lot of things that were surrounding it that's now in this material that's exploded, and it forms a new birthplace for stars. All right, back to the life cycle of our stars. So what's going to happen after this happens? Well, there are a lot of materials still left, and they will come back together, and it will actually form what's known as a white dwarf. A white dwarf still emits lots of light, or light, and a lot of heat. Let's put it this way. Some light and lots of heat is what white dwarfs emit, and when it's used up all that heat energy, it will just become what is known as a black dwarf. You can't even see them in the solar system, but we know they exist, and we know they're the results of a death of a star that was small to medium in size. You can't see them, but we know the gravitational force of them still affects other things around them, so that's how we know they exist. All right, what about our supernova? Well, depending on your size again, it could go one or two ways. A large to, let's say, an XXL star, will take this path. And if you are extremely large, you're going to take this path. Well, some of you already know if you were an extremely large star, you end up becoming what is known as a black hole. And we've talked about this phenomenon as well, that we do believe that a black hole is the gravitational center of a lot of the galaxies in the universe. So that black hole has so much gravity it can pull anything into it. And if you were a large to extremely large, you're going to become what is known as a pulsar or neutron star. Pulsar, pretty much kind of like it sounds, it flashes light on and off as it dies out. Alright, so now we have reviewed characteristics of stars, and we've also looked at how a star's life cycle depends on its size as to which direction it would go as it ages. Remember, our sun is still at this stage. It's still doing hydrogen fusion. It does have heavier elements on it already to date, and we'll be looking at them shortly. But it is middle age, so it's still got quite a ways to go before it becomes a red giant and then goes through the rest of the stages. Alright, that was life cycle of stars.